Okay, everybody. I think it's recording. So this was the final practice we were going to do before taking the quiz. Now, I saw a lot of things that people were making mistakes on still on this example. So let me talk about a few of those. First of all, before you left the day this was assigned, we had talked about how temperature is the manipulative. Temp is the manipulative, and that the responsive is volume. Now, what happened was, though, I kept seeing on the graphs that many of you were still putting temperature on the vertical and volume on the horizontal, even though that's not what this says. So if the manipulative is temperature, then that has to go on the horizontal. Manipulative goes on the X, M on the X. Responsive goes on the Y. R on the Y, M on the X. Now, another thing I saw a lot of is that some of you were misidentifying which one was manipulative because, again, you looked at this thing and you saw some key words here. You saw changing, you saw volume, and you saw Felix all together. And so because you're, oh, Felix is changing the volume. No, that does not say that Felix is changing the volume, but because those words are close together in your brain, that's what you're thinking. And so, okay, so volume must be manipulative and it's on the x-axis. No, because it says further over here, it says taking a container of air, he altered the temperature several times. He is changing the temperature. He's heating this gas up. And then what's happening? Well, the volume is changing because of that. The volume is responding to his changing of the temperature. So I hope you see that that's what's actually happening here. Now, in terms of the graph goes, hopefully it looks something like this. This is something else I'm seeing some issues with. Notice I have temperature labeled on the x-axis, and I have K for Kelvin in parentheses. I have the variable name and the unit of measure here. I have the same thing on the vertical. So I have volume on the vertical, and again, parentheses in mLs. Some of you are leaving that information off. Some of you aren't putting any of it down, and you don't have either axis labeled. That's a problem. Some of you have at least the variable names in place, like volume and temperature, but then you don't have the unit of measure on each axis. In parentheses, unit of measure. Just like it shows in the data table, notice the name of the variable, unit of measure. Name of the variable, unit of measure. Okay, now, to fit it on my grid, and you didn't have to do this, I think a lot of people went by 50s on the x-axis, but I had quite a few boxes available, 19 of them, so I went by 30s, which I'm not a huge fan of, but it seems like every graph so far I've been going by either 30s or 15s. And so what am I doing again? Going by 30s on the x-axis, 15s on the vertical. Again, I only have 17 boxes, so I couldn't go by 10s because my last data point would have been off the grid. So I had to shrink it down a little bit in that regard. Now notice, I feel like my best fit is pretty good here because it's close to this one, it's actually brushing the side of these data points. It's cutting this one. This one's on the upside. This one's on, you know what? Now that I look at this, maybe I should have moved it up a little bit further because it looks like all of my data points, except for this one and this one, are on the top side. Maybe I should have bumped my best fit line up, maybe just a little higher. Angle-wise, it looks good. Maybe it should have been bumped up a little bit higher. Whatever, I don't really care. To answer the questions, though, that go with the graph. Is there a relationship? Yes, there is a relationship. In other words, is the volume affected by the temperature? That's what we're asking. Is there a relationship? Is the volume affected by the temp? is the volume affected by the temp? That's what we're asking. Is there like, yes, the volume is affected by the temperature. That would be all you have to say. The volume is affected by the temperature. You could say that the volume gets bigger as the temperature gets bigger. You could say that the line has an actual slope, like it's not horizontal. The line is sloped. Doesn't have to be a straight line. Straight line doesn't say that there is a relationship. Horizontal can be a straight line, but that's no relationship. So the kinds of things you could use to answer this question, again, is that the volume is affected by the temperature. The volume got bigger as the temperature got bigger. You could say that the line has a slope to it. Any of those things would be a good answer for this question. Second question, is the data proportional? Yes. And how do you know? Linear, it's a linear graph, which means, again, straight line with constant slope / ratio. That's how you know it's proportional, okay? You know it's proportional because of this. You know there's a relationship because the line's tipped. The line is tipped. That shows you the volume is affected by temperature. There is a relationship. Is it proportional? That's a specific kind of relationship. So yes, there's a relationship. The line is tipped. Is the data proportional? Yes, because it's a straight line with a constant slope. Those are two separate things. There could be a relationship and the line could be curved. And so yes to relationship, no, it's not proportional because that line, that curved line, wouldn't have a constant slope. So it can be one and not the other. Now, it can't be yes for proportional and no for relationship, because if it's proportional, that means there is a relationship. But it can be yes for relationship and yet no for proportional if the line is curved and not constant slope. I hope that makes sense. Moving on. What temperature would be required to get a volume of 130 mLs? Now, temperature. It says what temperature would be required. It's asking for a temperature. Asking for a temperature, but you're given a volume. They gave you a volume. They're asking for temperature. So you go back to the graph and you look at the graph. They are asking for a temperature. Asking for temperature. But they give you a volume. So what do you do with that? Well, you start with what they gave you. You go to the volume. Now, because I went by 15s, it's kind of messed up. So if that's 120, that's 135. And so I got to break mine into like thirds. So that means this one would be 125, 130, 135. So this is my 130. And so what do? Well, I start there and I head over to my best fit line. And I stop at my best fit line. I don't go past it. I'm seeing some people go past the best fit, going to some random box and then going down. That's too far. You overshot. Oh no. Oh my gosh. Undo. Oh, no, yep. Okay. Apparently I don't have the erasers. There we go. Okay, that's better. Whew. That could have been disastrous. So once you get to the best fit, then you drop down on the other axis. And it looks like I'm right here in between 360 and 420. And so that would be, according to my graph, that would be 390 Kelvin. 390 Kelvin. So I hope you got somewhere around 400, give or take a little. That should be about where you ended up here. Maybe not exactly, but because again, we're all guessing on this. So that looks like 390 Kelvin on my graph. And again, what was your work? Your work was the dashed lines on the graph. You have to show me the dashed lines on the graph on the quiz so that I know you know where you looked to find that answer. Now, what volume did you get if the temperature was 480 K? Okay, so now we're looking for what? Looking for volume. They gave us a temperature. So now we have to start where? We start on the temperature axis. We start on the temperature axis at 480 Kelvin, and then we go up to the best fit line. You stop at the best fit line. Do not go past it to the next box. That's overshot. You don't do that. You turn left at the best fit. And I'm a little wobbly wonky here, but it looks to me like it's about 2/3 up on that box. And 2/3 up on that, if that's 150, then that's 155, that's 160, that's 165, which is right. That would be 165, that box. And so I'm here, I'm at 160 what? mLs. I'm still seeing people not put units of measure on your number answers. Oh my. So when you're answering this question, it is not just 160. Now, hopefully you got somewhere between like maybe 150 and 170. Hopefully somewhere in there. You don't just put 160. It's 160 milliliters. And again, how'd you show your work? You drew some dashed lines on the graph. I hope you're catching on here. Last thing, find the slope of the line and show your work below. Now you're going to have to sketch some things on the graph, but you're going to show your work where the question is being asked. I hope you're listening to that. So you could use the points we just found to find your slope. I'm going to go ahead and look for places of grid intersection, which, right here is a perfect one. Hold on, let me change colors. Oh no, where's my fuchsia? I want that. Okay, so this right here, boom, that's a good one. And I have another, right about, well, here's pretty close. We'll just use that. So I'm dropping it down from here. I'm bringing this across from here. And now I have to find out my rise and my run. Now, remember, here I went by 15s. So I went 15, 30, 45, 60, 75, 90. Okay, I went 90 what? mLs. Units of measure, people. Units of measure. Now down here I went by 30s. So 30, oh gosh, 30, 60, 90, 120, 150, 180, 210, 240, 270. 270 what? 270 Kelvin. That's my run. That's my rise. So then I go back. So I mark all that out. I show that on the graph. And then I go back to where the work's supposed to be done. And I say, okay, well, I'm finding my slope. So I say my slope is rise over run. And that is 90 mLs of rise over 270 Kelvin of temperature. Now, some of you don't like putting small numbers on top of larger numbers, and so that you have a decimal. You got to get over that. That's what it is. The rise is smaller than the run, which is why some of you flipped your variables in the wrong spot because you didn't like the fact that the big numbers were going to be on the bottom and the smaller numbers were going to be on the top or on the side. But that's the way it was. You got to follow what the variable names are and therefore where they go. So that is 0.33 for those following along at home. That's a third, right? 90 to 270, or 9 over 27, is a 1 over 3. That's a third. Now, it's 0.33 what? We can't get rid of the units of measure. It's mLs / or for every Kelvin. So again, if I'm reading that, it says to me, like I would say, that's 0.33 milliliters for every Kelvin. So how do you write that out in a sentence? I would add the variable names. It's 0.33 milliliters of what? Volume change. for every 1 Kelvin, right, of temperature change. So there are 0.33 milliliters of volume change for every 1 Kelvin, oops, oh boy, of temp change. Now you could also write 0.33 mLs to 1 Kelvin. You could write it like that, 0.33 ml to 1 Kelvin. At this point, I don't care if you write it like this or if you write it like this. I mean, this is how you would see it written, like in a textbook or something. Official, that'd be the official. This is, again, showing the ratio, 0.33 to 1 ratio. But this sentence here, and making sure that your variable names are mentioned, it helps explain what the slope is, okay? Having the variable names in there explains what the slope means. So that was it. We talked about that. If anybody had any other questions, we addressed them, we answered them, and then we took the quiz that looked just like this, but a different experiment, a different set of data, but all the same types of questions. Because this is the kind of thing we're going to be doing like all year with the data we collect. So hope this helped. We'll see you soon, I suppose. If you're not here, hopefully you come back soon. Take care.